Hello viewers, today we will talk about false position method, also known as regular fallacy. Our objectives for today is to explain regular fallacy method, find out root using an equation, make the convergence faster, and solve examples of false position method using manual and Excel. The poor convergence of bisection method as well as its poor adaptability to higher dimensions motivate the use of better techniques. One of such method is the method of false position. False position method is another bracketing method used in numerical methods to find the roots. It is similar to bisection method, and the only difference is the formula in solving or in getting the new value of the x. Recalling our learnings from bisection methods, if we already have the left and the right limit, we usually locate the midpoint to get the value of our new x. In regular fallacy, this is not the case. We will use linear interpolation method to get the value of our x. The false position is defined as the x position where the line connecting two boundary points crosses the axis. Meaning, if you put a straight line connecting two functions of the limit, the point where the x-axis and the line intersect is the value of our new x. For a better understanding, here is a figure. In their figure, we have our left limit and our right limit, and these are our functions. See? What we need to do is to connect the functions of the right limit and the left limit with a straight line. Again, the point where the line and the x-axis meets is the new value of our x. The line we use to connect segment line is called interpolation line. If the limits are not given, we have to guess two initial values such that the answer in the functions will result to a negative and positive value. So the formula, the intersection of this line with the x-axis represent an improved estimate of the root. To find the value of our x, we use the formula. X is equals to xl, or the left limit, plus the difference of the xr and the xl. Xr is a right limit, and multiplied with the values of our function of the left limit, which is yl, all over yl, minus the function of the right limit, which is yr. The formula was derived using similar triangle. Now, I'm going to show you on how did I come up with my formula using similar triangle. Here is our figure. First thing we need to do is to complete the base in the height to create a perfect triangle. Here and here. So how does the dimension of triangle relates to the formula? Here I'll show you. To find the height of our triangle, we will use the y values. Our y values are the yr, or the function of the right limit, and the yl, which is the function of our left limit. Since yl is under the x-axis, it is understood to be negative. Thus, we will have a formula of yr minus yl is equals to the total height of our triangle. The next thing we need to do is to find the total length of our base using the x values. Our x values are xr, or the right limit, and the xl, or the left limit. Always remember that the values of our xr is the distance from the y-axis. Same goes with the values of our xl. Therefore, we will have an equation xr minus xl is equals to the total base of our triangle. Since we need the values of the x, we will put a smaller line here creating a small triangle. The height of our small triangle will equal to yl, and the base of our triangle, or smaller triangle, will equal to x minus xl. By using similar triangle, we will take the base of our smaller triangle ratio with the height of our smaller triangle equal to the base of our bigger triangle ratio with the height of our smaller triangle. Multiplying both sides, and we will have an equation for x. X is equals to xl plus open parentheses xr minus xl close parentheses multiplied by the function of l, or the yl, all over yl minus yr. In solving false position method, we have these three conditions. First, if yl multiplied by the function of xn is less than 0, then the value of our left limit will retain. Hence, it will be changed into x. Second, if yr multiplied by the xn is less than 0, then the value of our right limit will retain, hence it will be changed to the value of. And lastly, if yl multiplied by xn is equal to 0, then x is equal to x and we will end the algorithm. Now, we have an example. Solve for the root of nonlinear equation using false position method. F of x is equals to e raised to the power of negative x minus x, and our initial points will be 0 and 1. The first thing we need to do is to put our initial points to their respective limits. 0 will be our left limit and 1 will be our right limit. The next thing we need to do is to find the function of our limits. To find the function of our limits, we will substitute the value of x to our initial points from the equation. So therefore, first, e raised to the power of negative 0 minus 0, we will have a value of 1. Next, substituting 1 to the formula, e raised to the power of negative 1 minus 1, and we will have a value of negative 6.613. Since we already have our limits and their functions, we can now solve for the value over x using our formula. xl, or the 0, plus open parentheses 1 minus 0 close parentheses multiplied by the function of L 1 all over 1 minus negative 0.613 close parentheses, we will have a value of x 0.6127. And to find the function of x, we will substitute the value of x to the formula, which is e raised to the power of negative 0.6127 minus 0.6127, and we will have a value of negative 0.708. So here are the values of our first iteration. Now, solve for the second iteration using the conditions that we tackled before. And you should have a value of left limit 0, right limit 0.6127, the function of our left limit 1, the function of the right limit, which is negative 0.070, our x will be 0.5121, and our function of x will be negative 0.007. Now, I'm going to show you how to solve false position method using Excel. So, solve for the root of nonlinear equation using false position method. And here is our equation, e raised to the negative x minus x. Our initial points is again 0 and 1, and to find the value of x, we will use this formula. So first, putting our left and right limit, left will be our 0, and right will be 1. So to find the function of our left limit, we will substitute the formula. So, is equals to ESP negative 0, or negative this panel, C10, close parentheses, minus, again, this panel. And we will have a value of 1. Next, to find for the function of our right limit, we will have is equals to EXP negative this panel, which is 1, close parentheses, minus again this panel, which is the value of our x. We will have a value of negative 0.63212. Since we already have the values of our limits and our functions, we can now solve the value of our x using this equation. So, x is equal to the left limit, which is 0, plus, open parentheses, the right limit, minus the left limit, close parentheses, multiplied by the left limit, or the function of the left limit, all over the function of our left limit minus the function of our right limit. So we will have a value of x 0.61270. To find the function of x, we will substitute to our formula equals to exp negative this panel, close parentheses. So we will have a value of our function of x negative 0.07081. So for our second iteration, we will apply the conditions. If the function of the left limit multiplied by the function of x is less than 0, the function of the left limit will retain, else x. Here, applying our second condition, if the function of yr multiplied by the function of x, which is the xn, is less than 0, the value of the right limit will retain, else change the value of x. So here it goes, copy. So here are our values. Since we already have our right and left limit, we can copy this. And here are the values of our second iteration. So since you already have the second iteration, you can find the other iteration by dragging down these panels. So as you can see, on the 6 iterations, the value of our function of x is 0. Therefore, our root is 0.56714. So that's it. That is how you solve false position method using Excel. Thank you for listening.